My name's Leah Martin. I'm a postdoctoral fellow at the University of Alberta. Thanks. Okay. So I'm going to share with you some of our work looking at one approach to improving Google Flu Trends estimates for the United States using transformation. And this is based on a paper that my colleagues and I recently published in PLOS 1. So most of you are probably familiar with this picture showing the overestimation by Google Flu Trends in the United States in red here, relative to ILI-net from the CDC in blue, particularly the 2012 to 13 influenza season. Here are transformed Google Flu Trends estimates in the light blue, which greatly reduce this overestimation and move the peak timing closer to ILI-net. So here's our transformation equation. This is how we develop these estimates. So the transformed Google Flu Trends estimate for this week is based on the preliminary ILI-net value from last week multiplied by two factors. First, the relative change in Google Flu Trends estimates from last week to this week relative to last week, and a transformation parameter estimate that we developed using linear regression based on data from 2010 to 2013. So in terms of timeliness, the preliminary ILI-net value is available Friday for last week. And as we know, Google Flu Trends are updated throughout the week until they're finalized on Saturday. So the transformed estimates can be calculated on either Friday or Saturday, creating 1 week difference from Google Flu Trends, and they're 1 week ahead of ILI-net. So we compared our transformed estimates to the original Google Flu Trends estimates and ILI-net's final values using three main metrics. So first, we looked at the 29 weeks that Google Flu Trends, that CDC defined as being above baseline for their values. And of these 29 weeks, we looked at how many of them were within 10% for our estimate compared to ILI-net. So for our transformed estimates, 17 weeks were within 10% of ILI-net compared to 2 weeks for the original GFT estimates, and 12 weeks for last week's preliminary ILI-net value. Then we looked at the sum of squared errors, so comparing the estimate to the final ILI-net value. And for our transformed estimates, this sum of squared errors was 12, which is much lower than Google Flu Trends and somewhat lower than last week's preliminary ILI-net value. So this last column here shows the most recently available data from the CDC, and the comparison to it demonstrates that Google Flu Trends provides some additional useful information about the final ILI-net estimate beyond this. And then we looked at the 2012 to 13 peak, and as you saw before, we did better. And then we expanded our analysis to the regions, and similarly, we did a good job here. We developed a different transformation parameter for each region, rather than uniformly just putting the 0.65 to all of them. So the same color representation, Google Flu Trends is in red, and our revised estimate is in blue. And then we looked at the 2013 to 14 season. So this is the revised Google Flu Trends model. So here our transformed estimates predicted ILI-net values well. They did a better job than the Google Flu Trends estimates, and then the preliminary ILI-net values as well. And then we further looked at the most recent influenza season, where Google Flu Trends introduced a new model. And our transformed estimates, again, do well at predicting ILI-net. And they reduce the peak in Google Flu Trends by a marginal amount. So in summary, overall, you can see that our approach is a stable approach because we can apply the same equation and the same parameter estimate over the entire 5 seasons. And our work provides an example of how incorporating the relationships between novel estimates and traditional values can improve Google Flu Trends estimates. So here's our paper if you'd like some more details. Thank you.